1.00 grams of mixture of calcium carbonate and calcium oxide liberated 0.33 grams of carbon dioxide and strong 18. The percentage of carbon oxide in the mixture is dash. Atomic mass of calcium is going to be 40, carbon equals 12, and oxygen equals 16. Solution. We have been asked to determine the percentage of calcium oxide in the mixture. To proceed with this, we need to write out the chemical reaction showing the decomposition of calcium carbonate on 18. And I would like us to note that the compound is a mixture of calcium carbonate and calcium oxide. So when calcium carbonate and calcium oxide react, calcium oxide does not decompose upon heating. So we only have calcium carbonate to take part in the chemical reaction. The calcium oxide will remain as a solid residue at the end of the reaction. So in the chemical equation we'll be writing now, we'll be having calcium carbonate CaCO3 to give calcium oxide. When calcium carbonate decomposes now, CaO and carbon dioxide CO2. So let's see if this is balanced. We have one atom of calcium present in the reactant side. In the product side, we have one atom of calcium as well. For carbon 1 in the product side 1, oxygen 3 in the reactant side. Product side we have 1 and so that's 3 as well. So we have a balanced chemical equation. In the equation above, the substance we'll be dealing with is just calcium carbonate and carbon dioxide. Based on the equation above, we have 1 mole of calcium carbonate to yield 1 mole of calcium oxide and 1 mole of carbon dioxide. So let's calculate reacting mass of each of the elements present. To calculate, we'll need to determine the molar mass of the substances first. So molar mass of calcium carbonate equals, that will be sum of the atomic masses of each element present. So we have calcium 40 plus 12 for carbon plus oxygen. 3 atoms are present, so 3 times 16. This is 40 plus 12 plus 48, which equals 100. And the unit grams per mole. For carbon dioxide now, so the molar mass of CO2 equals 12, the sum of atomic mass present of each element. For 12 for carbon plus oxygen, we have 2 atoms present, so 2 times 16 equals 12 plus 32, which is equivalent to 44. The unit grams per mole. We've just gotten the molar mass of each of the elements. Let's proceed to determine the reacting mass. So for calcium carbonate, based on the equation above, 1 mole of calcium carbonate yield 1 mole of calcium oxide and 1 mole of carbon dioxide. So the reacting mass now will then be the number of moles multiplied by the molar mass. Reacting mass of CaCO3 was 1 multiplied, the number of moles, that's 1 multiplied by the molar mass 100, which is equals to 100, and the unit now grams. Reacting mass of CO2. So let's calculate that of carbon dioxide now. See, 1, that's from based on the equation, that's 1, the number of moles multiplied by the molar mass 44. So that's 44 grams as well. We are given the mass of carbon dioxide that was produced on 18, but we do not know the exact amount of calcium carbonate that took part in the reaction. Do not forget that the compound that was heated is a mixture of calcium carbonate and calcium oxide. So then, to know the amount of calcium oxide present, we need to know the amount of calcium carbonate present. And that's what we are trying to do now. To determine the mass of calcium carbonate, we'll be using the relationship that says 100 grams of calcium carbonate yielded 44 grams of carbon dioxide, according to the equation above and our calculation recently. So x grams, because we do not know the exact amount that's decomposed, we yield 0.33 grams. That was what we are given in the question, of carbon dioxide, CO2. So now to get x, we'll be cross multiplying indirectly this and this. So x will then be equal to 100 grams multiplied by 0.33 grams divided by 44 grams. So this equals to 33 divided by 44, the unit grams, which is equivalent to 0.75 and our unit grams. So we have 0.75 grams of calcium carbonate. Meanwhile, in the question, we are being made to know that the mass of the mixture is 1.00 grams. Note that the mixture contains calcium carbonate and carbon dioxide. So mass of the mixture equals 1.00 grams. Mass of calcium carbonate in the mixture equals 0.75 grams. That's what we've gotten. Then mass of calcium oxide in the mixture we then equal to 1.00 grams minus 0.75 grams, each is equal to 0.25 grams. Then percentage of calcium oxide in the mixture now will be equal to the mass of calcium oxide 0.25 grams divided by the mass of the mixture itself, that's 1.00 grams multiplied by 100. So calculating this, we have 25 in the unit percent. So that will be all. And with this, we've come to the end of the solution to the question.